Hello, everyone. The asynchronous material for this slide relates to variability in a descriptive form, not including the terms variance or standard deviation. So variability refers to the extent to which scores on a quantitative variable in a distribution are spread. There are a number of ways of describing variability. The first and easiest, or also least informative, is the range. The range describes the space between the highest and lowest scores in a distribution, and can either be calculated as the range exclusive, which is the high value minus the low value, or the range inclusive, which is the high value minus the low value plus 1. So the range inclusive counts not only the distance, but the distance including the end score. The extension of the range is the 5-number summary, and that includes more information. It tells you the actual nature of the lowest score, the spread between the low and the high score, the score at the first quartile, the score at the median, the score at the third quartile, and the highest score. And we will look very shortly at what the quartiles and the median mean. 5-number summaries are often portrayed graphically with the use of box plots, which we will also procure in this video. So starting with the median is considered a robust measure of central tendency because it's not affected by extreme values. As you can see with these illustrations, the median is 5 for both of these two cases, which are alike, except to the extent that the high score in one, they have the same number of scores, and the median is the middle score. But in one, the high is different than in the other, which is more extended. But the median is still the middle score. In the bottom case, there's an even number of scores with 2 scores splitting, as it were, the middle, in which case the median, most simply calculated, is the average of those 2 scores. So I'm actually not going to go into the group data example because we will probably not be looking at group data in the future, nor am I going to go into the formula because the formula often doesn't match what you will get in other cases. And after numerous experiments with the formula that's in the textbook, I haven't found it to be particularly profitable. Another point about the median is that we do not use the median except for description. The median for inferential statistics or for making decisions about the relationship between a sample statistic and a population parameter is not used. The median is not used in that case. So the median is purely descriptive. So first of all, what are the quartiles? The quartiles are the values that separate various quarters, essentially, of the range of the distribution. The first quartile is the 25th percentile. So the bottom 25% of cases, the value marking the top of the bottom 25% of cases. The second quartile is the 50th percentile, which is also the same as the median or known as the median. And the third quartile is the 75th percentile. There are terms that we sometimes talk about, which are the interquartile range, also known as the H spread, which is kind of like a mini range. It is the distance between the third quartile and the first quartile, or the middle 50% of the distribution. And it can be used to describe not the complete spread, but the spread around the clump of the central tendency. Similarly, the semi-interquartile range is half of the interquartile range, and it further narrows the range to look at the most common spread of scores. So I have here an illustration of this with an ordered array of scores. Actually, I'm sorry, let's see if I can, I'm not going to correct that, but this version of the array, I'm trying to get my window away from all the scores, which I can't do. I'm not sure how to do that, so I'm just not going to bother. But we have here, an array of, I believe, 27 scores. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. Yeah, it's 27 scores. These are continuous data. Not all of them are unique numbers, so we can assume that they are probably measured on a continuum. So what we want to find is the median, the first quartile, the third quartile, the minimum and the maximum, so we can construct the 5-number summary. Now, to do that, we have to put them into an ordered array. That means order them from bottom to top. And then we have to construct the frequency distribution. So I have already done this for you. I did this in SPSS. And what we see once these values are put in order, and by the way, SPSS does not account for any gaps in the distribution because it's continuous. You really don't know how many values are possible between 4 and 4.3. It might go to 4.01. And so we don't put in the zeros for missing values. But the frequency of 1 in this data set occurs once. The value 2 occurs twice. Let's see where. Here's a 2 and here's a 2. The value 3 occurs once, and so on. The next thing it tells you is the percent frequency. So a value of 1 out of the total number 27 counts is 3%. The value of the value 2, which has a frequency of 2, occurs 7.4% of the time in this distribution. The valid percent is going to be redundant with the percent when all cases in the distribution, all 27 of these values, comprise all the possible cases. So you've got 27 cases in the distribution, and each of them has a score on this variable. So in this case, each case in this distribution has a score on the variable that we're calling raw. And then we want to find the median, first quartile, and second quartile. So what we look at is the cumulative percent. Okay, so at the value 1, we've accumulated only 3.7% of scores, but when we add 2 more scores, accounting for an additional 7.4% of frequencies, we have now accounted for 11% of scores. We add one more value, we've accounted for a total of 14.8% of scores. We add 2 more values and we go up to 20.2, and this value, the top value, will always count for 100% of the scores. So what we want to know is for quartile 1, what value includes the 25th percentile. So you see, we don't have any value that is actually at the cumulative percent of 25. The percentile of 25% is somewhere between this, but it is within this interval of 4.3. When you get to a score of 4, you have not yet reached the 22nd or the 25th percentile, and you have reached it when you get to 4.3. Similarly, the value that contains the median, as it were, the interval that contains the median has not yet been reached at a score of 8, but it has been reached by the time you get to 10. The value that includes the 75th percentile would be in the 16th interval, and the value that includes the max is, which is at the 100th percentile, is 30. So I've circled each of these values. So to write the 5-number summary, we would say 1 is the minimum, 4.3 is the range at the, or the interval at the 25th percentile, 10 is the interval at the 50th percentile, 16 at the 70th percentile, and 30 at the 100th percentile. Now, this output is from a something called the explore command in SPSS, which we'll look at later. But it gives you the mean, which is always a useful thing to know. It gives you the median at the 50th percentile, the minimum, the maximum. So those are now 3 of the 5-number summary. This does not give you the first and third quartile, or the 25th percentile and the 75th percentile, but it does give you the interquartile range, which is third quartile minus first quartile. So our third quartile was 16, our first quartile was 4.3, and so our interquartile range is 11.7. We can, however, easily get to asking for the percentiles in SPSS, and so I will show you how to do that shortly. You see here the percentiles that we calculated. You also see these different kinds of percentiles, which are known as Tukey's hinges, and they're calculated slightly differently. They are used in some depictions of box plots, but not all. So some box plots will look slightly different than others, depending on what they're using, what you know as Tukey's hinges, or the normal percentiles. Tukey's hinges are certainly not necessary for this course. And really, in a publication, I've never seen anybody distinguish which kind of percentiles they are obtaining. Although when you're doing coursework, it's never a bad thing to be thorough. So particularly if you are doing Tukey's hinges, you should report that you're using that. So here you can see the box plot, also derived using the explore command in SPSS. Here is your the top line represents the maximum score, and that's going to be true whether you use Tukey's hinges or not. The maximum score in this distribution is 30. The bottom line is going to represent your lowest score. The top and bottom of this is the interquartile range, the blue area. The line through the middle of the blue area is always the median, or 50th percentile. And if we go back we will see that the regular percentiles were 4.3 and 16. The Tukey's hinges were 4.65 and 15.5. And I've provided some extra detail, which you can do in SPSS by getting a grid that includes every single interval of a whole number. And you can see that this top line of the interquartile range, which is 75th percentile, is not actually at the value of 16, it's at 15.5. So the quartile in the output that is generated by the explore command in SPSS uses Tukey's hinges. Again, this is a minor detail, but if you're looking closely at your box plot, if you've constructed it using Tukey's hinges, which you would basically not do if you were doing it by hand, you'll see that it looks a little bit different than what you would calculate by hand using the frequency distribution table, which is what I've illustrated here. Let's actually now modify this array slightly. And what I've done with this modified array is I've changed a single value. And that value is, I have a new value in here of 50. And that is different than an existing value in the old distribution. Every other value is the same and the number of values is the same, but I've simply substituted 50 for 30. You'll notice that the quartiles don't change. The quartiles are unaffected by the values in by the percentiles in by the individual values, I'm sorry, in the distribution. They're really just the place order weighted by how frequently places occur. But the nature of the variable, the value of the variable that occurs in any place order is not important. What changes is the minimum and the maximum, particularly the maximum. And so our 5-number summary is different only in the maximum value because that's changed from 30 to 50. If you were to construct a histogram for this variable, and what you would see is that this 50 makes the distribution of this, if you were to kind of try to draw a normal curve over this, extremely skewed, positively skewed, because you have this crazy 50 outlier that has a great spread from the interquartile range. The 5-number summary pretty much shows this, but the percentiles and the interquartile range do not. So there's something to be aware of that particularly if you have a very skewed distribution in either direction, you may want to use the 5-number summary or some other histogram, or for instance, the box plot to show not only the interquartile range or the median, but the outlier scores. So what you'll see is that the top of the distribution now does not, the line doesn't convey the maximum score. What you receive is you receive information about the box plot. I'm sorry, about the outlier. And they report this thing with a score, which is that 27 there is the case number in the score. It's not the value. The value appears on the y-axis. So what SPSS and will mark this in a particular way as an outlier. And with various way people show these, maybe a dot, maybe a star, but it's some way to depict that there is a particularly unusual score, and it is defined often as an observation that is more than 1.5 times the value of the interquartile range. And it's either below the first quartile or above the first quartile. So our interquartile range there, I believe, was, let's see, go back. The interquartile range was 11.7. That's not changed by this outlier score. And the distance between the quartile 3, which is 16, and 50 is more than 1.5 times whatever that interquartile range. I can't remember what that was. I'm sorry. You can go back and look at it again. So we are now going to move to replicating these steps in SPSS using the descriptive commands that I have shown you thus far. So I've pulled up these data in SPSS. These data are the original, what I've called variable 1, where case 12 has the value of 30, variable 2 has the value of 50. So it's the skewed distribution with the positive skew towards the high outlier score. These are just ID numbers that I used so that I could sort the data in ways that they were not already in the order of a frequency distribution. So let's first get that frequency distribution. And to get the frequency distribution, you go under Analyze. Analyze has a lot of the ways you obtain descriptive statistics and inferential statistics. Transform is usually the way you, in fact, it's always the way you create new variables or change existing variables. Data includes things like how you sort. Graphs obviously includes graphs, and those are going to be the main tabs that you'll use. So in this case, we already have the data. We're not going to change it in any way. We don't need to sort it because the output of the frequency distribution will show us its sorted value with the counts within each value. So to get the frequency table, you simply go under descriptive statistics, and ask for frequencies. So you choose your variable, you click on the arrow to bring it one way or the other, and you tell the program that you want the frequency table. The frequency table is the default in SPSS because the assumption is that you're going for frequencies, you want the frequency table. Sometimes actually I like to use frequencies for various kinds of statistics. Note that you can get quartiles here. You cannot get quartiles under other descriptive commands. So I will often use statistics for variables here under the frequency command, but I'm not going to do it right here. There are also charts available, and I often use this to create a histogram. But you can do that also in other ways. So I'm going to get the frequency table for variable 1, replicating what was in the previous slides. And you see that all cases in the data set have a value on variable 1. So that means that our percents and our valid percents are the same. There's no adjustment to the valid percent for the fact that any cases had missing data. And these are the same values that we saw before. The value that contains the 25th percentile is 4.3. That contains the 50th percentile is, is in the space between the 48th and the 51.9th. And so it's given the value of 10 and so on. 16 as the 75th percentile, and 30 is the maximum. So the way to get the quartiles in SPSS, the easiest way I know, is also to go under descriptives, also to go under frequencies. And in this case, I'm going to ask for the quartiles, which, because the 50th percentile is a quartile, will automatically give me the median. Note that you can also get the mean, which I'm not going to bother to get right here. And I'm going to turn off display frequency tables because I've already gotten that. So I'm just going to not get it again. It really doesn't matter if you have too much output that you don't need in SPSS. It gets very bulky. And if I haven't already, I will close this by showing you how to get editable output where you can take things out that you don't want. So, okay, I want the quartiles for variable 1. And I get a summary of how many value points. I am always going to be checking to make sure you can still see these, that there are in the distribution, and then the first quartile, the median, and the top quartile. Notice that those are not reported with Tukey's hinges. If you want the box plot, there are other ways to get the box plots. So one way is graphs. The graphs function in SPSS, chart builder is their fancy function. It is annoying, but you still have legacy dialogues. Legacy dialogues, not to go into nauseating detail, but SPSS, we're now in version 25 and has added a whole lot of ways to do things and new things to do, like the Weibull plot, that it didn't used to have. It used to be a much simpler statistical package. And because people liked the old ways of doing things, you've already seen sometimes there's multiple ways of doing things. And so the legacy dialogues tend to be simplified ways of getting things that you can do under Chart Builder. So we're just going to ask for the box plot, a simple box plot. I don't think the data and the chart are, they're not separate variables. We're only looking for one variable. Our variable is variable 1. We have no category. Variable 1 has no categories. And we're not going to, sorry if there was a brief gap there. I realized that variable 1 hadn't been a scale variable up here, so I couldn't obtain the box plot. So I'm getting back to making my box plots. You can only get box plots on continuous variables. So it was in here as a nominal variable, which wasn't right. Good reason to always check this column in your variable view. So now getting back to legacy dialogues and the box plot, what I want is a summary of a separate variable, variable 1. And I'm going to define it, which is just to tell it that I want the box to represent variable 1. I could have a second box plot along the side for variable 2. And I don't think we'll show that at this particular time, but we might. Let's see what's under options. It's just issues about whether or not you do it for all cases, and whether that's if you have multiple variables in your box plot or not. We're not going to worry about that at this time. So what does our box plot look like? It looks exactly like the box plot we obtained before. Top value is 30, bottom value is 1. This is Tukey's hinge, and this is Tukey's hinge. So that's one way to obtain a box plot. Another way is just to go back to the statistics and ask for, instead of the frequencies command, the explore command. And what's kind of nice about this is I love the explore command personally because it gives you a lot of stuff. So our dependent variable, that's our continuous variable. Factors are often variables that are categorical. So like a variable that represents treatment or no treatment. We're going to go into those things later. But what we want is our dependent list, our continuous variable that we want to see on this. The display default here is that I want both statistics and plots. And that's what I'm going to ask for so that we can look at both. So the statistics I want are the descriptives. There will be a lot of descriptives. I said at the beginning of this that the output that I showed before for Explore does not include the percentiles. You can get the percentiles here, but you can't get the quartiles. So you'll have to look at all the percentiles. That's okay, you can get them. Or you can go back to frequencies and ask for the quartiles if you need them. And then under plots, we're not going to ask for stem and leaf. I've already stated my prejudice against stem and leaf, and we're not going to, we'll go ahead and ask for that histogram. Since we only have one dependent and we have no factors, these questions are irrelevant. And we get the descriptive statistical output, the mean, the median, the variance to standard deviation, which we'll look at in another video, the minimum and the maximum. The median, again, I may have already said, so that's 3 values from the 5-number summary. And we got the other value under using the frequencies command for the quartiles. And this is the distribution. It's somewhat skewed, but you'll see down here at the box plot, the spread up here shows you the skew, but it's not so skewed that we get outliers, which would be marked with a star. If we ask for exactly the same data with the variable 2 instead, we're going to see a box plot that includes that outlier, and we can also ask for a histogram that will show us the relative size of distance or spread of that outlier. So in this case, we're going to use a second dependent, a second continuous variable. We could do this separately, but it's actually kind of interesting to do them both together, as particularly when you get to box plots. So we're going to put up variable 2, and I think we're only going to ask for plots because that's all I want to do. And you will always get the box plot, but we're going to get the dependents together. So we're going to get variable 1 and variable 2 on the same plot. And then we're also going to get the histogram, so you can just see the difference in the shapes of those two distributions. So what I'm going to see here is, this is the histogram of variable 1, which I just looked at. And this is the histogram of variable 2, which has that outlier score of 50. Notice that the mean here is 10.3, and the mean here is 11.13. So the mean, which is said to be sensitive to the value of scores, is different based on the fact that there's this high score. And the mean in a skewed distribution will always be skewed, will raise with a positive skew relative to other values, and it will go down in a with a negative skew. And that up or down is relative to the median. So you see the median in these two distributions is exactly the same. And the interquartile ranges are not displayed here because you have this gigantic distortion that is the outlier score. So you can see that here, oh, I'm sorry, not the interquartile range is, I can't tell quite if it's the same or if it's different because they use Tukey's hinges, which tend to make things different. But these lines representing the minimum and the maximum. Minimum is the same, but and this is the maximum, but this value here is not the maximum because the maximum is distorted. So I believe that's everything that I went through with the numerical values and things that you might be able to do with hand calculation, and then the SPSS steps for calculating those things, meaning that's the end of this particular presentation. And I hope you all found it somewhat informative.